Today we're doing the first day of section 4.8, and that is finding the inverse of trigonometric functions. So we've already talked about the inverse notation when we did SOHCAHTOA, but again I just want to go over that notation. So when you ever see a problem that looks like this, so instead of a y it will say theta equals sine, and it has this little -1 of x. What this essentially is saying, the way we pronounce this, is the inverse of sine. It does not mean 1 over sine of x. So at any given point today, when you see this notation, again, that means I'm talking about the inverse of sine. So we're going to talk about the process to finding the exact value of the inverse of sine. So it's a three-step process. The first step is if we have theta equals the inverse of sine, we would take this notation and we're going to rewrite it as sine of theta equals x. So again, when you're finding the inverse, you're essentially just trying to determine the value of the angle or the theta that was used. So we've done this with a calculator. We're going to try and phase out the calculator and just use our knowledge of the unit circle. One thing that we have to know is that when you're finding the inverse of sine, it only applies to negative pi over 2 less than theta less than or equal to pi over 2. So if the angle that's given is greater than pi over 2 or smaller than negative pi over 2, you cannot find the inverse. So the table that we're going to use for sine, we're going to use the following angles. So our theta section, and then we're going to have our sine section. So again, this is essentially kind of like coming from the unit circle. So we'd have negative pi over 2, we have a negative pi over 3, a negative pi over 4, a negative pi over 6, and a 0. Then we have all of these but the positive version. So pi over 6, pi over 4, pi over 3, and positive pi over 2. So we're going to think about our coordinates here and figure out how we would find sine. So let's start at the positive end, since that's something that we have a little bit better understanding of. So we know pi over 2, the coordinate is 0, 1. So that therefore sine of pi over 2 is 1. So if I ever want to know, well, what is the inverse of sine of 1, the answer would be pi over 2. For pi over 3, we know the coordinate is 1/2 and a root 3 over 2. And again, sine is the y part of the coordinate, so pi over 3 would be a root 3 over 2. We know pi over 4 is root 2 over 2, root 2 over 2. So pi over 4 is root 2 over 2. And we know pi over 6 is the opposite. Pi over 6 is root 3 over 2 and a half. So pi over 6 would be a half. And for 0, the coordinate for 0 is 1, 0. So sine is 0. Now, if you think about the even and odd identities that we talked about, if I'm finding sine of a negative pi over 6, I know the negative goes out front, and now the answer is just the same. So again, let me just jot this down in a different color so you understand what I'm saying. So if I asked you to find sine of a negative pi over 6, I know even and odd identity says that the negative can go out front, and then I find what sine of pi over 6 is, and I make my answer negative. So using that logic, I know if there's a sine of a negative pi over 6, the answer is still going to be a half. It's just going to be negative. So this whole chart is going to kind of repeat itself just with negatives. And here's a negative root 3 over 2, and here's a negative 1. So this is the chart that you need to know for sine. Again, this is one of those things that you have to memorize. You pretty much already have it memorized. You know the coordinates. It's just we have to kind of think about them in a different way. So we're going to do an example just focusing on sine for now. So for our first example, the directions are going to say find the exact value of the inverse of sine of root 2 over 2. So again, the way we go about this, the first thing we would write is that theta equals the inverse of sine of root 2 over 2. And we want to get that out of this notation and write it in a different way. So the way we would want to write it is that sine of theta equals root 2 over 2. And now we kind of think back to that table, and the only place that you get a positive root 2 over 2 happens at the angle of pi over 4. So the answer to this problem is pi over 4. Now, again, the goal would be is that you're not using that chart. You're trying to do this from memory. So let's try another one. So the directions say find the exact value find the exact value of the inverse of sine of negative 1/2. So again, I'm going to kind of just skip right to that step where we're rewriting it. So we want to rewrite it that sine of theta equals negative 1/2, where negative pi over 2 is less than or equal to theta, less than or equal to a positive pi over 2. So again, we're thinking about that chart. I know a 1/2 comes from the denominator of 6. I'm trying to think of when the 1/2 is in the y part of the coordinate, so that would be a pi over 6. And since the angle's negative, the answer is negative, that means the angle is negative. So our theta is negative pi over 6. And that would be the answer to the inverse of sine of a negative 1/2. Last thing I'm going to go over is how to find the exact value of cosine inverse. Oh, don't know what happened there. Alright, so finding the exact value of the inverse of cosine. And again, same thing, we use that same notation of the inverse of cosine x. So step 1 is to rewrite this theta of the inverse of cosine of x. You want to rewrite this as cosine of x, or sorry, cosine of theta equals x. Now, cosine has a different restriction on theta. 0 is less than or equal to theta, less than or equal to pi. So notice we have a different set of values that you have to know. So again, we're going to kind of make our chart that we can use. So here's my theta, and we'll make our cosine list. And again, this list is going to be different, so I'm going to go from 0 to pi over 6, pi over 4, pi over 3, pi over 2. And again, we're going to kind of keep going. So if you're thinking about the unit circle, we're now dipping into quadrant 2. So 2 pi over 3, 3 pi over 4, 5 pi over 6, and a pi. All right, so let's go through this chart and fill out our chart. So again, I know cosine of 0, the coordinate is 1, 0. Cosine is the x part of the coordinate, so the answer is 1. For pi over 6, I know the coordinate is root 3 over 2 and a half. Cosine is the x part of the coordinate, so root 3 over 2. Pi over 4 is going to be root 2 over 2. Pi over 3 is 1/2 and root 3 over 2, so the x part is 1/2. And for pi over 2, the coordinate is 0, 1, so the x part is 0. So now we're going to go into quadrant 2. So 2 pi over 3, I know goes back to the 3 coordinate. I'm in quadrant 2, so the x part of the coordinate is negative. So that means this answer is negative 1/2. Again, 3 pi over 4, I'm using this coordinate here. I'm in the second quadrant, so the x part of the coordinate is negative. And 5 pi over 6 is this part here. And again, negative. Pi is directly to the left, and we know that coordinate's a negative 1, 0. So the x part of this coordinate would be negative 1. So this is the table that you need to know for the inverse of cosine. We'll do some practice on cosine in class tomorrow, but that's it for today.